Good afternoon, everyone. Hope you're well. Thank you very much for joining the second webinar of Allinea on the CSCS systems. My name is Patrick Wolschlegel, and I'm the Technical Services Manager in Allinea. And basically, what we're going to discuss today is GPU debugging with Allinea Forge, which is available on PeaceDate. So the agenda for this session is, first of all, to a very quick introduction about GPU and many core architectures. We'll rediscuss also very quickly what we have done last month. So last month we had another webinar, which was how to get started with Allinea DDT on PeaceDate. So I'll spend maybe 1 or 2 minutes discussing about this. And once we're done with the slides, I'll move on to a live demonstration focused very much on GPU debugging on PeaceDate. So using the system, I will show you how to get started with CUDA debugging or OpenACC debugging. It's all the same. We'll have a look at memory debugging very quickly. There will be another session which will dive much more into the details of memory debugging, so I won't spend too much time on this today. But we will see how to control debugging session on GPUs, how to visualize data on GPUs, including the host memory and the GPU memory, because these are two different things and we don't want to mix them. And by going through this small example, I will show you how to resolve one problem that can happen on GPU when writing code. And of course, if you have any question, I'll be able to demonstrate this for you. So there's already one question coming up. So are you going to also look at debugging OpenACC codes? So the example I have created for you today is based on CUDA. If we have time, Jean-Guillaume can also show how it works with OpenACC, but basically it's all the same. There is no difference at all when you're debugging on GPU, whether you're using CUDA or OpenACC. The debugger behaves exactly the same, and I will show you how it is the same during this session. Okay. So if you have any question during this session, please do not hesitate to ask in the chat. Apparently there is a small problem when we are trying to send messages to everyone on the chat, so it's not possible to broadcast messages. So if you have a question, please send it directly to myself or to Jean-Guillaume. His name in the chat is JG, and we will be very happy to answer any requests that you may have. So let's get started. First of all, just wanted to discuss a bit why people are using accelerators. The reason is very simple, is because it's probably the most efficient hardware available on the HPC systems at the moment. So basically, all the machines that are the top or in the Green 500 are all based on accelerators of some kind. So it can be FPGAs or GPU accelerators. And for many years now, this kind of machines are dominating these records. Now, what is interesting is looking at the Green 500, accelerated systems are first, but when we look at the top 500, which is the list of the most powerful HPC systems in the world, what we can see is that the adoption is not so great. So only 10% of the machines in the top 500 are using accelerators at the moment. So this means that the penetration of these accelerators in HPC systems on an everyday use is actually quite low. So why is it? Why is it so slow to take off? Because it brings a lot of value for when running application. So there can be possible reasons, maybe because people are not too sure about the future hardware that people are going to use, and they don't want to get into one machine type of machine too drastically. Maybe it's because that migrating the code is difficult. And I personally think that this is the main aspect, because when you want to use GPUs, you have to change, slightly modify your code, rewrite it in order to run on these machines. So in Allinea, what we do is we make it easier. So basically, again, we have two different products. We have Allinea Forge, which is here to help people migrate and design applications. So if you're moving your application from CPU to GPU, we can give you the tools to find the problems and make sure that this goes as smoothly as possible. And when you're using applications in production, we also have Allinea Performance Report, which is a tool that allows you to benchmark code, monitor the efficiency of your application, including on the GPUs, so you can measure the GPU usage, the memory usage, are you using shared memory, are you using global memory, these kind of things. And this can help you maximize the number of runs you can do during your allocations. So what we have seen last time when we were discussing about the tools is what you have and how to get started with this. So as a very small reminder, in CSCS, you have a very big Allinea Forge license, which contains debugging mainly. So you have an Allinea DDT license for 65,000 processes. That's a lot. And you can also debug GPUs with this. So you're very, very welcome and more than encouraged to use this tool if you have problems. And you also have a profiler called Allinea Map that is available. It's a trial license available that allows you to profile codes for 30 seconds, but it's there if you want to try it. So when we were discussing last month, basically we had a look at the getting started. And here's a reminder of what we discussed. First of all, if you want to debug your application, you need to use the -G option when you compile your code. So this is mandatory because it is necessary to generate the symbols that the debugger needs to look at the variables, look at the call stack, etc. We also recommend to use low optimization flags, for instance, O0, because otherwise there may be some inlining, some variables may not be visible. So it's more intuitive if you use low optimization flags. But if you have a bug that only happens with an optimized binary, in which case you can use it, it will work, there won't be any problem. It may just be a bit counterintuitive at times, but you will be able to debug your code. So to get started, we have seen how to start with the remote client, installing it on your laptop, how to create a connection to PSDaint, how to connect using the reverse connect command. So we are going to see this quickly again today. And we've also seen attaching and offline mode, which is debugging an application without any graphical interface. Now, knowing all this, we will reuse all this that we've seen. So I assume that you all remember what has been done. If you haven't seen the video, it is online on YouTube, so you can see it again, no problem. You're very much invited to do so. But using all this, we will now deep dive into GPU debugging using Coda. And to achieve this, I will go through a live demonstration showing you how to get started, how to enable memory debugging on GPUs, how to control and debug the GPU kernels, stepping warps, for instance, how to look at data, depending on the context, on the host, on the GPU, and we will resolve a small problem on a dummy code.